Alright, reducing fractions. This is when we get to use what we just learned about equivalent fractions. And this is one of its applications. So what reducing means is to take a fraction and make it, we're not actually making it smaller. It's the same exact size fraction. What we're doing is trying to get it to where the numerator and the denominator have no more common factors. Nothing left that we can actually divide out of them. So what you do is you just pick a number that you know 24 and 60 both have. So for me, I see a 2. And that gives me 12 out of 30. Look at them again, and they still have a 2, which gives us 6 out of 15. If we look at those, they have a 3, and that gives us 2 out of 5. That's it. And then we check it. 2 times 3 is 6. 6 times 2 is 12. 12 times 2 is 24. 5 times 3 is 15. 15 times 2 is 30. And 30 times 2 is 60. So this is our equivalent fraction. Do you remember all those tests for divisibility? If you haven't seen them, there's a test for divisibility video. You want to watch that one. It'll actually tell you how to tell which of the 4 base primes, 2, 3, 5, or 7, these two numbers share in common. So I want you to try it here with 25 and 65. Oh, before you do that, it doesn't matter what you pick. Remember, we can do any number you want. So if you saw 12, right off the bat, you get 2 out of 5. It takes you straight there. The 12 is our GCF for the 20 and 60s, which we'll learn next time in the next video. But I want you to try now numbers 1, 2, and 3, and then stop. So just give those 3 a shot. Hit pause on your video and try them. Alright, and these are your answers. So the first one, you could have divided by 5 and 5, and then 5 and 5 again, but you should have gotten 1/3. Number 2, it's fully reduced. And how would you know? Well, what you want to do is look at the number at the bottom. That's a 6. And if you do our prime factorization, 6 is made up of 2 and 3. So if 151 does not have a 2 or a 3 as a factor, then this will not reduce. And we already know that 2 does not work because it's not even. And for 3, if you add up the digits, you get 7, which is not divisible by 3. So it is fully reduced. You just have to check the smaller number. They must contain the same number because we're dividing top and bottom by that same number. And if you go to 36 and 16, you should have gotten 9/4. Alright, what about if we have these little variables in there with exponents? Well, you want to first take the 24 and the 60, and you can reduce that by itself. So we know that those have what in common? Okay, the 12, we did that earlier. So that gives us 2 over 5. And then we put it back in place. 2 over 5. And then you want to write out the exponents. That's what x squared means, and that's what x means. So now that we have them written out, we can just cancel them. And this leaves us with a 2 on top, and a 5 and an x on the bottom. And again, these are called equivalent fractions. Because we have just reduced it, it's still the same fraction, it's just in a more simplified form, which is why we call it reducing. Another way that you could do this is to just do it all at one point. Write out the x's, and then just slash. And then with the numbers, you can divide, but make sure you say it. 24 divided by 12 is 2. 60 divided by 12 is 5. So each of those is a little division by 12. And then you can just write the answer, which is 2 on top, 5x on the bottom. Make sure if they're on the bottom, they stay on the bottom. If they're on the top, they stay on the top.